So I'm going to be, as Mandy said, talking about actual performance. But first, before we start, I'd like to thank the brand agency for hosting this event tonight, and thank you to Mandy, rather, for getting this whole group organised and sorting us into line. So thank you.
I did forget to say thanks to Brand, but yeah. Sorry. Yeah, thanks for the reminder.
Yeah, no worries. So my name's Dan. I'm a web developer at Humaan, predominantly in the back-end area, but front-end is my front-end performance and back-end performance is what I'm really into as well. So as of the 1st of April this year, the average page size for the top 100 websites was 1.3 megabytes. For the top 1,000, however, it was about 1.9. This is mainly related to images, Flash, yes, unfortunately that's still around, and JavaScript. So what do these kind of results say about the current state of front-end performance? Well, first off, it tells us that the top 100 companies, or websites rather, they have the time, budget, manpower, or people power rather, to dedicate to optimizing performance as much as they can. So if we could all be so lucky, eh? So most of us, if not all of us, are constrained by time, budgets, clients, and we don't really have time to basically do anything other than getting the website up for them. We don't get to finesse those little details just to make the site a little bit faster. So all websites scraped on the HTTP archive at the 1st of April, they were 1.9 megabytes again. So it's a bit of a discrepancy between the top 100 and basically the rest of the websites. It's 600 kilobytes. So the total size of websites is growing year by year, but it's mainly related to content. But we could be doing things better, really. So what can you do about this? Well, you're probably thinking, well, I don't have a multi-million-dollar budget. I don't have 50 people in my team dedicated to squeezing every byte or every nanosecond out of my websites. So you're probably thinking you're screwed, eh? I know, sometimes I thought that too. Well, you're wrong, sorry. There are heaps of little tips and tricks we can do, and I want to run through some of them with you now. It's not a catch-all. All these little tips, implement them. If you notice bad side effects from that, maybe don't implement it, but question how you're doing it in the first place. But yeah, just give them a go. So first off, if you're using Modernizer, please never ever use the development build in production. There's a huge amount of tests in there that test everything. If you don't need to run that test, don't run it. Tests like tests for like a web GL, they can take up to a couple of seconds to run. So if Modernizer is waiting for your test to run, your HTML is going to have no CSS classes added to it. So if your CSS relies on those classes being there, the user is going to have a couple of seconds where they're seeing your site possibly unstyled or not reacting to the CSS capabilities being run. So if you're using something like Flexbox or some other CSS which isn't quite implemented properly in all browsers, you should consider inlining Modernizer in the head. You do take a bit of a cacheability hit, but when it's all about kind of performance and even perceived performance, they're not going to know. The user doesn't care what's in their cache. If they see it load that little bit quicker, or they see less of a flash of unstyled content, the better. Also, Modernizer does come with the HTML5 shiv by default. Take that out and put it in a separate file along with respond.js, and chuck that in a separate file and conditionally load it for IE8 and below. Of course, you can do that with conditional comments. So another critical thing really is HTTP requests, or minimizing them rather. So every request you do to a unique domain name requires a bit of overhead internally. Each domain name resolution check to convert the domain name to an IP address can take anywhere between 10 to 120 milliseconds for each domain name. So it doesn't sound like much if you're doing 1 or 2 domain names, but if you're sourcing content from a number of different domains, sorry, I shouldn't have said that, that's the wrong way out. If you've got all your content on one domain name, and you've got something like 30 or 40 requests, the browser can only handle 8 requests, or 8 concurrent requests at a time from the one domain name. So what you can do is something like sharding, which is basically where you've got a domain name, say google.com. You can add a CNAME record, which is basically an alias for the domain name, just cdn.google.com. So that would be pointing to the same address. When a request hits cdn.google.com, you've got a little initial overhead of the domain name resolution, but once you're past that, you've got 16 concurrent requests all downloading, rather than 8 and another 8 being stuck in the queue. So very clever people like Yahoo's Steve Souters have run quite a lot of tests on the best amount of domains to have in your kind of shard. Anywhere between 2 to 4 CNAMEs or shards is the best. Once you start going into kind of 5, 10, then you're really slowing down performance again because you've got to do your domain name resolution checks. So that's one thing to consider. Another thing is concatenation. So I don't know if you guys have seen it before, or if you're copying a 1 gigabyte file, it'll copy, the 1 gigabyte file will copy quicker than 110 megabyte files. That's because each individual file, there's a little bit of overhead in the system related to opening and closing of the file headers. So that's the same with downloading files. You've got the initial check, you've got the post-processing once it's downloaded, just making sure the file hasn't been corrupted. So if you can concatenate maybe 10 JavaScript files that are probably, maybe 5, 10 kilobytes in size just into one bigger file, you've got one file to download instead of 10, and you don't have heaps of domain name checks to do, and it's one item coming down the queue rather than filling your queue. Images. So as I mentioned before, one of the main factors of page size was images. Most images that you would save probably from Sketch, Photoshop, Pixelmator, Paint even, they all store hidden comments, extra metadata that could be related to that program that they were opened in, or saved in, or altered. They aren't necessary for when the user browses your site. They don't get anything out of that. So you can use tools like ImageOptim, JPEG Mini, Image Alpha. All of them are fantastic tools for compressing files. Most of them are lossless optimizations as well. So if you're using PNGs, go with ImageOptim. You can usually get, even if you do a save for web in Photoshop, you can usually get about 50% file size reduction, which in itself is pretty good. And that's in ImageOptim, it is lossless. You can also run JPEGs in ImageOptim, however it's not very good for that. You probably get about 5% reduction at most. So you use something like JPEG Mini, which you can get, again, about 50% compression. However, you can sometimes have a bit of quality degradation in your images. However, my recommendation is run it through JPEG Mini, have a look at the photo and compare it to the original. I've been using JPEG Mini for about 6 months. Easily less than 1% of every single JPEG I've run through it has had a loss of quality. So it can happen, but it's quite rare. If you don't have the resources to manually run your images through through the applications, or a client is managing their website, You do have cloud services like Kraken or even Tiny PDF or tinyjpeg.com. They're in my reading list as well, which I'll talk about at the end quickly. And they've also got WordPress plugins, so if you've got a client on WordPress, every time they drag and drop image into the attachments area, WordPress in the back end will send that image to one of those cloud services, compress the file, send it back to the website. It's seamless, they don't have to do anything. So that's a really handy little tip as well. Another really useful thing is lazy loading images. So say you've got like a huge site or a huge page, and when the user loads that browser, or the page, sorry, they can only see kind of about 10%. Normally your browser will download every single image because they're just in line in the HTML. That's not really good practice, really, because the browser is downloading those images that probably aren't going to be seen for, depending on how long it takes to scroll down. It could be 5 minutes before that image is even anywhere near the viewport. So you can use lazy loaders. My favourite one is lazy sizes. I should have that in my reading notes as well. So what that'll do is you hold the actual image URL in a data attribute in the image tag, and then this JavaScript, what it does when you get, say, 300 pixels, or you can customize it, when you get the viewport is close to that image, it'll start loading the image and then replace the data attribute with the source attribute, and so the image pops up, and the user hopefully would never know that that image wasn't loaded until a couple of seconds ago. Alternatively, if it's going to take a little longer, you can just have a little loading animation. One thing that I see a lot of people get wrong is use JPEGs for photos, not PNGs. JPEGs are terrific at doing compression on files that have thousands or millions of colours, whereas PNGs are not. So say, for example, I had a photo of me and Andy Clark. That JPEG was 1.5 megabytes.
Because you got it framed, right?
It was a special one. That photo, when I opened it up in Photoshop, didn't alter the dimensions of the photo in any way. Just opened it in Photoshop, did a save for web, set it as a PNG 24, and that was 10 megabytes in size. So that's nearly 3 to 4 times the size, which is just unnecessary. So unless you've got a really good reason not to use a PNG for a photo, like maybe you've got alpha transparency in it, try to avoid using PNGs for photos where possible, and it's not a catch-all. So these are my image optimization results. So for the PNG, that was about 500 kilobytes before optimization. Then running it through Image Optim, it got down to below 250. So it was technically about 55% smaller. And then the JPEG was just under 1.8 megabytes in size. After running it through JPEG Mini with no visible image degradation, it was 770 kilobytes. So again, huge optimization, and people who are viewing the website cannot tell a difference between the two images before and after optimization. I challenge people to tell the difference. Don't challenge. So another trick or technique is content minification or uglification, depending on your words. So when you're in a development team, or even just, you probably should be documenting some of your code at least, just in case you come back to it later on. Comments are great for the dev team to see. Say if you've got a function, this function needs to do this exact thing, don't alter it for the 10th time. Sometimes those comments have to be there, but the user who downloads the page doesn't need to see the comment. I'm sure that only 1% of people even view the source for a website. Chances are if they view the source, they know what's going on anyway, so they don't need to see the comments. if it's say one comment, you know, it could be 10 bytes, but that can start to add up. If your comment, your code is well documented, which yay, you could be filling your CSS or JavaScript with 10, 20 kilobytes of unnecessary data. So while 10 to 20 kilobytes doesn't sound like much, if you have millions of people viewing your website every day and you're paying for bandwidth, you're losing a hell of a lot of money. Or not you, your bosses, and they will find out. So another thing that the minifiers can do is change your kind of long descriptive variable names to something shorter. It doesn't change the functionality of the code. The code still runs the exact same way. It just shortens the names of the variables. It's all about squeezing every single byte out possible. And if you can, it's not always possible, but if you can, put your script tags in the footer. It just helps prevent the browser from blocking your page from loading. So at least you can get pretty much all of your page downloaded before it starts loading.
I was just going to point out with regards to minifiers, you've got to be careful with some of them because they can rearrange code and sometimes break things.
Good point.
Sometimes I think if you have test coverage, you can pick up those things.
Very good point.
You were late. Questions at the end.
Oh.
That's a very good point. So I hope you're testing. If you're not, at least run your code through the minifier. It can sometimes screw up your code, so just check it at least. Don't minify it and then go live straight away. I hope you're testing. So yeah, you can use a JavaScript loader like require.js, head.js, no, enhance.js. I could go on all night talking about different JavaScript loaders. Kind of onto JavaScript performance. If you're doing an event if you're doing a function that kind of relies on the scroll or resize events, don't bind your function directly to that event. If someone's scrolling very slowly, or if they're doing a lot of scrolling and your code runs a lot or is quite intensive, or if there's a lot of alterations to the DOM, it can slow down your website from scrolling, and you're going to lose that nice buttery scrolling effect. So what I recommend is using something like a throttler. So you can use _JS, they've got one. So basically it just prevents the function from running, or it binds the function through the throttler, which prevents it from running more than say 100 or 200 milliseconds. I had a function for a website where when you scroll down, the menu would shrink. Before I put that throttler in, it was every time you scrolled, regardless of the position, it would always rewrite that navigation or add the classes to the DOM and cause a repaint every time you scrolled. Adding in simple checks for classes to see if the navigation was a certain size or scroll position, just cut down. I think that every time before optimization, every time you scrolled, the function took 7 milliseconds to run. When I got it down as fast as I could, if you scrolled and there were no operations to be done, it was 0.3 milliseconds. So I'm kind of a micro optimizer sometimes. You don't have to go to those depths, but it all adds up, so they say. And another kind of little thing to do is for like jQuery, React, Angular, or Bootstrap, if you're using those libraries, which is okay to use a CDN to load that content or those libraries in initially, if you can, or if it's appropriate to do so. Chances are, particularly if you're using jQuery, if you're using the Google CDN, most users probably have that in their cache, so it does save them 30 to 60 kilobytes of downloads. What you can do is you can write a little bit of JavaScript just to see if the Google CDN jQuery hasn't loaded within half a second or a second, however long you want. Fall back to your own jQuery file, and don't concatenate it with the rest of your JavaScript. as well, just so they can download it off the CDN or fall back to yours if necessary. So these tips, I've kind of given you guys a bit of a brain dump, I apologise, but if you can take a small amount of time out of your day, night, whenever, if you're on the bus, the train, going to work, don't do it in your car. If you're driving, see if you can but see if you can implement some of these techniques. You don't have to do all of them, and you don't have to go crazy JavaScript optimizer like I can be sometimes. Even just lazy loading images, it'll probably make a difference to your site. Your users will thank you, as Mandy said. All these little kind of tests that big websites have done to see content or user drop-off, it's phenomenal. I just wanted to talk about one more really quickly. Amazon did one a couple of months ago where they delayed their page, all their websites loading for some users by about 150 milliseconds, I think it was. They saw a 6% drop-off of purchases. It doesn't sound like a lot, but when you factor in how many sales Amazon do every day, 6% is a huge amount. So bear that in mind. A little personal case study of mine where I kind of implemented all these tricks in. I had a client who had a big products page, about 50 products or so, each with an image and a hover image. Now, initially, when you browsed that website, if you got to the bottom, it was 12.5 megabytes. That's disgusting. And even on my original iPad mini, it would crash the browser because there's not much RAM on there. So this was due to pretty much every reason, really. There was no concatenation of files, no minification. A lot of JavaScript had been kind of added in, and then don't make that function run ever. So it was just sitting there in the source code, never ever running. So dead code essentially. Also, images were downloaded at 600 by 600 and then scaled down to 200 by 200. So terrible waste of bandwidth. I think each image was coming down at about half, kind of anywhere between a quarter and a half a megabyte each. So not great. I spent probably about a day working like mad to refactor this site. Got it down to 2.5 megabytes once you scrolled all the way down, just with a really clever usage of images, really using lazy loading, optimizing the JavaScript to hell and back, and it only took a day, and the client loved it, and I could view it on my iPad mini and it wouldn't crash, and there was no dead code as well, so there was nothing wasted. Now, the future is where it all changes. So, no doubt you've probably heard of HTTP/2. So, it's based on the Google's Speedy protocol, or SPDY. It significantly lowers the cost of multiple requests to the same domain name. Once it initiates a connection to that server, it keeps that tunnel or pipe open rather than traditional open-close for each file. So it lowers the cost of multiple files significantly, and it does a technique called multiplexing, where unlike a, say, traditional plumbing pipe where water will go one way, like HTTP 1.1 is at the moment, you can actually get data coming both ways at the same time. So that's really good. So using techniques like inlining code, doing sharding, concatenating, even doing image spriting, that will actually be worse off, just because your users will be downloading all this content that they don't necessarily need and can get very easily. So say if you have an about page, when the user visits that about page, they would require only just the about page.js, about page.css, just the bare minimum required to render that page rather than most of the site's code. In relation to images, WebP, something else by Google, I believe, is a new image standard, web photo. It really combines the best of Jpegs and Pngs. You've got the excellent compression of Jpegs and the alpha channel of Pngs. So you can get full transparent images, like photos, and they are about 30% in size smaller than the optimized images that I did before. So with that same photo JPEG before, that was kind of around that area as a WebP, it was about 10%, 20% smaller, whereas the PNG went from about 200 kilobytes to about 80, I think. So huge benefits to be gained by WebP. That's supported in Chrome, Firefox, and possibly Opera as well. And that's it. My slides and reading list, just in case you didn't catch all of this, slides and reading list at the following URL. Thank you.